it's muted. Yeah, so you use the -y just so it installs the default settings. So once you have Node.js, npm, and then run the npm init, you should be able to have a basic, should just be the package.json file. Yeah. So I'll give you a few minutes to make sure everything's set up. And also, you want to install Postman, which will be a REST client. I'll talk more about this in the later slides, but just make sure you install this so you can follow on some of the content with the APIs. Okay, hopefully that's enough time. If you're still installing that should be fine. So move on to the introduction. So firstly, why do we need Node.js? So Node.js is a cross-platform runtime environment, and that lets you run JavaScript on a server. So normally you have HTML, CSS, and JavaScript that you run inside your browser on like your laptop. That runs client side, and then with Node.js you can run the JavaScript on a server. So that'll be server side. And Node.js allows you to serve static files, so like images, text documents, and it can also handle like HTTP requests, like GET and POST requests, and also manage databases and more. So it's mainly commonly used to build backend servers and APIs, which we'll be doing today. So HTTP requests, there are four main ones that you would use. So the first one is a GET request, so it retrieves data from a server. So maybe like something like fetching an image from a server. A POST request would be sending new data from the client to the server to create a new resource. So for example, you might be submitting a form for a membership. So you'll be sending this from the client and sending all that data to the server. A put request would be updating an existing resource with new data. So for example, it could be updating a password for a membership and then just making sure it's sent to the server. And a delete request, which is just removing a resource from the server. So HTTP request components. So there's four main components that are within a HTTP request. So the first one is the request line, which includes the HTTP method, so like get or post, the URL and the version. So most of them are like 1.1 or 1.2. So the headers are key value pairs providing metadata. So most of them for your browsers would have a user agent. So it'll be something like Firefox or Chrome. There's also the most other common one is content type. So for example, you might have application/JSON. So you'll be sending JSON data to the server. Or in example, in the response will be text/HTML. So you're receiving a response which is of the type HTML. And optionally, you can send a body, which is just optional data with the request. And this can be used for like a POST request or a put request. So REST stands for Representational State Transfer, and it's an architectural style for designing networked APIs. So it's mainly just a framework to build good high quality APIs. And so it uses HTTP methods, like I mentioned before, to interact with these resources on the server. And the resources are identified using URLs, so like /users or /post/one. And RESTful APIs are stateless, which means that each request contains all the information required to process it. So it doesn't need any extra other requests to complete that certain task. And REST clients, so the one that I got to install is Postman. So that's one of the most common REST clients. So REST clients basically just allow you to test different APIs. So you can send like GET requests, send POST requests. You can have a look at the responses for different API requests. And there's some alternatives like Insomnia, Advanced REST Client, and curl, which is more terminal line, which basically do the same thing. And I'll show you an example of how to use it. So this is Postman. So basically, there's this website called random duck. It just basically gives you a random duck image. So whenever you click on the image, it just gives you a new image of a duck. So in this website, it has an API. So it follows random-d.uk/API/version2, and it has a few endpoints available. So the one that we're interested in is the /random, which is returning a JSON object with a link to the random image. So if we copy that link into Postman and you send it as a GET request, it'll give you a response of JSON. So it'll have a message as well as a URL. So if you click that URL, it automatically puts it in the Postman. And then if you send a GET request, it gives you an image of a duck. The /crack is basically the same. /random image basically just be doing the same thing, but just gives you the image directly. And then there's a few other endpoints you could use, as well as one for POST requests. We'll talk more about how to use a POST request later. So Express. So Express is basically a backend web framework for Node.js usable servers and APIs. And APIs basically let different software systems exchange data. And Express basically just handles all that routing, the request processing, and all the middleware integration that would normally be required for a server, and you can use it through code. So the first important thing of Express is routes. So routes define how an application responds to specific HTTP requests. And each route matches a URL part and a HTTP method. For example, here you have a /duck, and it's just a GET request, and whenever the server receives that request, it sends a response of crack. So in Express, the routes are created using methods like app.get for GET requests and app.post for POST requests, and so on. And routes can return HTML, JSON, or any other type of response to the client. And they can be grouped and organized using routers for a more modular structure and for better code maintainability. And middleware, so functions that run during the request response cycles are middleware. So when the request is received from the server, the middleware is first called, and then after the middleware runs that logic, it does actual logic for the response, and then it sends it back to the client. So the middleware can basically modify the request and the response objects, and it can be used for things like authentication. So for example, if you're checking if a user has access to a certain page, you would use middleware to check if they have the permissions, and if not, you can send like a 403 forbidden or like redirect them to the login page. You can also use it for logging or parsing request bodies and error handling. And the middleware can either be built-in, third-party, or you can make your own custom one. So an example here is a built-in middleware to parse JSON. So it's just express.json, and you can just call it by using app.use. So let's make a new simple Express app, just to see how it works. Firstly, you want to run npm init, so it generates a package.json file. And then we want to run npm install express. So it installs the required modules and dependencies for the Express module. And then you'll see it'll create a new folder, node modules, with a bunch of dependencies, as well as a package lock JSON file, which just gives you the specific versions and the hashes. So now we can make a new file, so we can call this server.js, so it's just a JavaScript file. So we can start off defining Express. So we can do a constant express is equal to require express, so that's just importing the module. And then you can make a new app, express, and then we can make a new default route. So you can just do app.get, so that's when you get a get request on the default route, so you can just use slash. And then we can do response.send, can do hello world, I guess. So whenever it receives a get request to the default route, I'll zoom it in. Yeah, that's better. Okay, so we're just making the default route. So whenever it receives a get request, it can send hello world. Then we just close that. And then to run it, we have to listen. We can define a port that will be used, so we can define port and set it to 3000, and then we have to make it listen, so app.listen using the port 3000, and then we just send a console.log to make sure it's working properly. So you can start this by calling node server.js. I have to save first, and then it says service running on that. So if we copy that into a new page, it should return hello world. And if you go back to Postman, you can send a get request here as well, and it should give you the same thing. I'm just going to add another API route, so I'm just going to do another get one. So this time it'll be /doc, and then I can just send crack as a response. Yeah, so in Postman, when you do the /doc route and then send that get request, it just returns crack, which is what we want. So moving on to SQLite now. So firstly, what is SQL? So SQL is structured query language, and it's a standard language for interacting with relational databases. And it's used for create, read, update, and delete data, often referred to as CRUD operations. So SQL works with tables made of rows and columns to store structured data. So some main concepts for SQL is in the tables there's a primary key which uniquely identifies a row, for example an ID. You can have foreign keys, so if you have multiple tables you might want to have a foreign key which refers to another table's primary key. You can have not null, which is where a field must have a value, so basically just not null. There's a few data types, so it can be null, integer, real, which is just basically a floating point value, text, and blob. And blob is just basically raw data, so it can be like an image or binary. And booleans can be expressed as integers, so 0 for false and 1 for true. Relationships, so there's 3 main types of relationships. So the first one is one-to-one. It's not really used, but it's still there. So basically a row in table A is linked to exactly one row in table B, and vice versa. One-to-many, which is more used, is where a row in table A can be linked to many rows in table B, but each row in B links to only one row in A. And then the last one is many-to-many, so there's rows in table A can be linked to many rows in table B and vice versa. So for example, here is an example of a many-to-many relationship. So a customer can have, multiple calls, and same with an employee can have multiple calls as well. And some basic SQL commands. So for example, making a new table, you would use that create table. In SQL, sometimes they just write it all in caps. For some reason, it doesn't really matter. It should work either way. But yeah, for table creation, you can use create table and then define the columns. So for the example, it's making a new table docs with an ID, name, species, and age. When you insert data, you just do insert into the table name and then the IDs and then the values. If you're deleting data, you can just delete from the table, and then you have any like criteria to delete. And then selecting data, you can use the asterisk to select all the items from the table, and then you can do from whatever the table name is. Now SQLite is a lightweight self-contained SQL database engine, and it stores data in a single file on disk. So it doesn't need a separate like server or service to run. And it supports standard SQL queries for creating, reading, updating, and deleting data. So MongoDB is not a widely used database system. So I thought I'd just go over the main differences between SQLite and MongoDB. So SQLite is relational based, so it's actually SQL. So it has all the tables, columns, and rows, where MongoDB is no SQL database type, meaning it's just structured JSON basically. So it's more flexible. MongoDB is more flexible since the schema is not really fixed. It doesn't have defined tables. SQLite has a more fixed schema. SQLite's more better for lightweight apps, embedded systems, and local storage. You can still deploy it on the cloud and make it production ready though. MongoDB is still better for scalable, more dynamic applications, especially when you're working with more complex or varied data. Okay, so now let's try to make a SQLite database. So firstly, we need to install the SQLite 3 node package. So we stop that, and then npm install SQLite 3. And then install all the required modules and dependencies for that. Now we can make a new JavaScript file. We can call it init db.js. So we have to just import SQLite first, and then we can make a new database, and we can call it ducks.db, since we'll be adding ducks to it basically. Now we can use db.serialize, so it's basically just running db. So then you can call db.run to actually run SQL command. It's creating a table if it doesn't exist. So this is important to avoid overriding the table or making duplicate tables. So you can call it ducks, and then it'll have an ID of integer, and you set that as the primary key. Have a name, that's a text type and that's not null. Age can be an integer, that's not null. And then we can have species, that's text and that's not null. And then we can just do a console log to make sure you know what's happening. You can just say ducks table created or already exists. So if you're making first time, it'll just make a new table. If it already exists, it won't make a new one. And then we can close that. And then finally we have to close the database connection. So similar thing, you can use node to run the files. So we can do node init db.js. Oh, syntax error. And an extra comma. Oh. Okay, so now it's ran successfully. So it should generate a file called ducks.db. By default, VS Code would show this as a binary file, so it'll probably just not show anything. But if you're using VS Code, you can install this extension called SQLite 3 editor, and it basically just lets you view and edit SQLite databases. So if you go back to this file, you can see that there's the columns we made, so the ID, name, species, and age, and it's in a ducks table. So now we need to add some items to the table. So let's make a new file, so we can call it add ducks.js. Same thing here, we have to add SQLite 3. And then we want to open the database file. ducks.database. So we want db.serialize, and we do const insert. So this is just an insert command, so we have to do db.prepare and then insert into ducks. So insert into the ducks table, and we have name, species, age, and then values will be question marks, so that's just a placeholder. And then we want to add the values, so we can do insert.run so we have a name, and then we have the species, and then we have the age of the duck. So if you just duplicated that 2 more times and then just change the values, and then we want to finalize insert, and then just to confirm, we can have a console.log. You can not that, so you can actually do basically select all the ducks from the database and then print it nicely. So we can do new line all ducks, and then for each row that's returned from running the select command, so basically just selects all the ducks from the table, and if there's an error, then it raises an error. Otherwise it will log the ID, log the name, log the species and age. And then we can just close that. And then finally we have to close the DB connection. So now we can run the file, so node add ducks.js, and then a list the ducks that were added. So we have 3 ducks in total added. If you go back to the ducks.db file using the extension, you can easily see, and that's been added here. Okay, so now we want to try to integrate the Express app that we made before with this new SQLite database. So let's see how we can do that. So we go back to the server.js file. Importing Express, we have to import SQLite as well. Import up there, and then we want to use the middleware. So we're using the express.json, so that's just parsing the JSON. We want to connect to the database, so connect make a new connection to the docs.db database, and then get rid of the default route. So now for the /doc route, instead of sending just plain text, we want to query the database. So we want to run db.all, so select all the docs from all the entries from the docs table. If it has an error, it can just return 500, and then it'll give you an error message. Otherwise, it'll return the rows structured as a JSON object. So if we run the server again, it returns the JSON response with all the 3 docs that we had in the database. So we've done a get response now. So now we want to do an post request, so we can actually add new docs to the database. So we can do that by doing an app.post using the same /doc route. And then we want to do so basically we'll have to, when you're sending it from the client, we'll want the name, species, and age fields. So you'll have to put that in the body. So basically it'll have to parse that. So you need the name, species, and age. And also, if for some reason it's not there, you can just set it to undefined. You can just do a check. So you can do if there's no name in the request, you can just return. You can return that. Missing doc name. So if you don't have a field called name with a value, it'll come up with a missing doc name error. So we can do the same thing for the species and age. Missing doc species, missing doc age. So now we want to insert into the database. So we can do insert db.prepare insert into docs name, species, and ages again. And then we want to run that command. If there's an error, it'll just return an error again. Otherwise, it'll return 201. So that was successful. And then it can return a message as well. So we can just add doc added as a message to response, and then it'll be an ID. You can just return the ID. And then we just want to finalize that insert command so it actually runs. Yeah. Thanks. Yeah, so when you close that and then restart the server, should be able to have the post request. So if you send it with no body, it should return an error. So for example, missing doc name. So if you send a body, so in Postman, if you do raw and then do JSON, so you just have to add the name. You can call it doc. Species, you can make it a rubber duck. Age, you can be 1. So when you send out post request, the server adds it to the database and then it returns a response with a message duck added, and it returns the ID as well. So when you send another GET request to the server, you should be able to see that there are now 4 ducks here with a new rubber duck added. So now we've done the GET request and a POST request for getting the ducks and deleting the ducks. So now we want to do one for deleting the ducks. In order to delete them, we need to have some unique identifiable information to select them. So we can use the ID. So we can do /doc :ID. So that :ID can be, well, when you do it, it'll be like /1, for example. And then you send request response. So you can do a constant ID. So you're getting processing the data and then getting the ID from that. You can just call it duck ID. And then we call the command, so we can do db.run delete from ducks, where the ID is, that. So again, if there's an error, I can return an error. If the duck is not found, it'll return a 404. Otherwise, it'll respond with duck deleted.
The ID duck db.run needs to be duck ID.
Yep. Duck deleted.
And you haven't closed it off yet, but it's still going to.
Yep, so now when we do a delete, if you do /duck/ if we want to delete the rubber duck, so it has an ID of 4, it sends the request, it deletes the duck, sends a response saying duck deleted. If you call the duck /duck route send a GET request, it should just return the original 3 ducks that we had before. Okay, so now since we have the backend done, now we want to make a simple front end so we can actually display the ducks. So the project structure, so we're going to have a separate folder for the backend and the front end, just to make sure it's more clearer. So if you make a new front end folder, you can run npm create read at latest and then select React and JavaScript. And you can call it front end, and I'll make a new front end folder for you. So we can do that now. npm create. Before that, make a new backend folder. Move all this to the backend folder. And then using read, so we use this in the last intro to React workshop. So this is just mainly for single page apps using React and JavaScript. You just say yes, and you can call it front end. Select React and then JavaScript, and then you can just copy and paste these commands. So install all the required dependencies, and then it'll start the server. So if you copy that, it should show you the default starter page, which is just a little count button with some logos and links. So basically we don't want that, we want some docs. So we can go in the, firstly we go in the backend folder. So now we want to add some images to the docs. So we'll have to change the init db.json file, or .js file, sorry. So we have ID, name, species, age. We can add an image, and we can set it as text. And this will just be a link to our external image hosted on some place. So if you save that, delete this docs.db, C to the backend, init the db again, and then if you check the file, it should have another column for image. So now we need to update the add docs file. So you want to add image here and another placeholder. Add can basically use whatever link you want. I just have some saved beforehand, so this is just some random docs based on what species those docs are. And just add, so the last two will have the same photo. And then just update this. So when you add it, it actually logs it. So if we save this and then run the code again, and docs.js, I should log all the IDs, name, species, age, and now image for the 3 docs. So if you see in the file here, it'll basically be a link. So if you copy that, it's just a picture of some docs. So if you start the backend again, node server.js, and get docs, it should have this image field as well. So now we need to update the server.js. So first of all, we need to use app.use cause, which is basically just allowing making it not complain about it being different applications, so you can talk to the front end and back end properly. The duck route doesn't need any changes and just returns all the fields. So when we're posting a duck, we need to include the image. So include missing duck image, and add image here as well. and then the delete should be fine. So the backend code should be all good now. So now we need to modify the front end code. So basically in the template code, it has a main.jsx. So basically that's just the root files, and has an index.css, which is just some default styling for some of the elements. There's app.css, which is more specific, and then app.jsx, which we'll need to modify. So we can start off by making a new component. So components in React are just more modular pieces of code. So we can call it .jsx. So we can import useEffect and useState from React, and then make a new function. And then we call, so using useState, we call doc and then setDoc. So that's just setting all the variables. Initially it's null, since we have to fetch it from the API first. And then we can update the value, so we can do so using useEffect. So we can call fetch localhost/doc, and then in a response, and then passes it as JSON, and then using the data you can set it as using that data you can set docs to that data, and then if there's any errors you can catch it and then log the error, and then close the thing for that, and then we want to return the HTML code. So we can have a div, and then we can have each do docs, and then we can have, I'm just going to be using some inline styling for the CSS, so you don't have to worry about external files. So we can do just going to copy that. So it's just adding as styling to make it a grid, add a 1 rem gap, and then set the grid template columns to repeat, and then it has a min max to make it look a bit nicer. So inside that div, then we want to make a map, so docs, hold it, I'll call it docs. So basically map, so for each doc we want to make a new section of code. So we have a div, and then will be a key for each doc ID, and then we can have a styling, same, okay. So it just adds a simple border, some padding, and a border radius to make it round the corners. And then we want move the image first, so we can have an image component. We set the source to the doc.image. We can have an alt text of the name. Styling, you can just set it to 100% width. And then we can add you can set the height to auto, so it automatically adjusts it. You can make an object fit cover, so it just covers the image, stretches it as needed, and adds some random quarters. So we set duck name as a h3, so a smaller header. We can have a species as a paragraph, and then duck age paragraph, and then close the div. And then lots of brackets, and then finally we have to export a component. So we can do export default duck list. So now we can go back to app.jsx and then basically remove most of this code. So we just want to import the component that we just made, so duck list. From duck list, and then inside here can make a new div, and then just apply some styling to the div. So it just adds a padding and that sets the font to Arial, and then we can have a header. Header you can call a duck dashboard, and then we can insert the component duck list, and then it exports the app. So if we start this up. Firstly we have to install, on the back end we have to install the cores module to fix that. And then after it's installed, still doesn't work. Express. We have to import it, yeah. Schools, require course, and then it should work. So we start the back end and then start the front end. So if you open Firefox, it should show you duck dashboard, and then has the images and the names and species and age. If you go, I'll change the URL. So if you go back to Postman, you can see the same thing. That's just a raw HTML, and then you can sort of preview it. No. So now if we use Postman to add some new ducks, as duck, so we can do the same thing. Need an image URL. So you can just copy the image. So we send that /duck post request. Need a comma there here, and then it says so receives it properly, and then the server sends a response duck added. So if you refresh the page, it should show the new duck, rubber duck. And then same thing, if you want to delete it, you can do /duck/id, so the same ID is 4, and then it deletes duck, and then it's gone. So that's basically using Express, SQLite, and then just a simple front end using React read and JavaScript, and then from here you can basically expand upon that further and make some more interesting projects. So that's all of the workshop content. Just lastly, want to just advertise the open source team again. So obviously I'm one of the open source infrastructure manager, and then we have Azrit and Justin, who's open source officers. So basically, if you want to build software, open source software, mainly like web devs projects like this, you can come work on some of the projects we're working on. If you want to learn more, there's a link to our website page and the GitHub link. So we have several different projects, mainly web dev, but there's also some more Python and then C++ projects as well. And then if you wanted to join, I mainly just join the CS Club Discord server and then get the open source role and then read a wiki as well. And then it should just tell you onboarding steps and how to get started, how to set up all the different projects. And if you want to give some feedback for this workshop, just scan the QR code, and then it just takes you to a Google form and you can just add some feedback there. So that's the end of the workshop. So thank you for everyone who came today. The pizzas, I believe, are set up there. So you can just line up and then get the pizzas.